Hello everyone, welcome to our daily physics problem, day 15. So today we have a magnetic field problem again, but this time we have a circular ring of radius r lying on the xy plane carries a steady current I moving counterclockwise, viewed from positive z direction as shown in the figure below. What is the magnetic field at point P on the axis of the top of the loop, at a distance z from the center? Write the answer using the sum of all the following. I, R, Z, mu 0, uh, I hat, J hat, and K hat. So I want to pause the video, try on your own. After you try it, come back to the video and show you how I did it. So welcome back, guys. So as we did before, we need to lay out the general integral for our magnetic field, which is B of point P is equal to mu 0 times I divided by 4 pi to the integral of the ring times ds vector cross product of r hat divided by r square. R is the distance between the source and the viewpoint. Then we need to find our expression for each of the term. What is ds in terms of what we know? Let's put it in polar coordinate since it's a ring. It's a natural coordinate system. So we have r times d zeta times zeta hat is the normal direction of the ring. Then we have r hat is just equal to r hat, well, in polar coordinate. Then we have what is r square? We know the distance will be using some Pythagorean theorem. I know it's r squared plus z squared and square root. And then if we want to get a square, we can just square root and then square. We get back to our original equation, r squared plus z squared. So now we have our components right out what we ever know in polar coordinate. Now let's plug it back into our equation and integrate it from 0 to 2 pi since our integration variable is theta. And it's a ring, it's a closed ring. So let's just copy and paste them in. We have ds cross product times the height hat divided by r squared. Okay, now let's integrate this part. But first, let's solve for the cross product. What is theta hat times r hat is equal to negative k hat as our right hand rule. But we need to notice that the r is from the source to the position, and so r hat is actually negative r to our coordinate system. So our k hat will be positive. And also, don't forget that this r hat is the a unit vector from the source to the position, not only the horizontal component. So we need another expression for our r hat. How can we express our r hat in terms of thing we know? We know we can decompose the vector into two vectors. One is in the y direction, one is in the z direction. So r times negative r hat plus z times k hat. That's our vector. Divided by its magnitude, we get our unit vector. Then we don't forget our denominator, r squared plus z squared. So now we can think another vector cross product, which is theta hat times k hat will be equal to r hat according to your right hand rule. So now let's write it more simply. We have our original equation, and then we have r times r squared, and then multiply these two vectors, we got k hat divided by r squared plus z squared plus r times z times these two vectors multiplied together, cross product is r hat divided by r squared plus z squared. Oops, we need to just common denominating the denominators. So we got another 3/2 exponents there. And then all of them need to be integrated over d theta. But now we need to remember, because we need to express our expression in terms of uh, uh, Cartesian coordinates. But now we are in polar coordinate, so we need to transfer our r hat into our Cartesian coordinate. And we need to define our theta. Then we can lay out this expression: r times cosine theta times j hat plus r times sine theta times I hat divided by r, because this can be simplified to r. And r will cancel out, we get our expression for r hat. Then we just plug them back into our equation. We have this formula plus this formula times cosine theta times j hat plus sine theta times I hat. Then we need to integrate them all over d theta. Don't forget about the integration variable. Now we know the integration variable is theta, but in the whole equation there's only two places of theta, it's cosine and sine. So only need to integrate those components. Other things that treat them as constant. We know cosine and sine are oscillation, a periodic function that's over a period of 2 pi. So the sum of the region cancelled. So they should be 0. So this term just be 0, and this term just gone completely. So now the only term we left is r squared over r squared plus z squared to the 3 over 2. And that is all constant. So integrate that, we get another theta. And then we have integrated from 0 to 2 pi. Then we have this expression here. 2 pi and 4 pi cancelled out. We have divided by 2. Then our final equation will be mu 0 times I divided by 2 times r squared divided by r squared plus z squared to the 3 over 2 to the k hat direction. That's our final solution.